Hello, welcome to everyone in this video. Today we want to discuss about the solution of the paper CC4, that is Wave and Optics for semester 2 on the year 2022 Physics Honors, Calcutta University. You can see the total question paper. This is question number 1, 2, 3, then question number 4, 5, 6 and 7. I request all of you first try to solve this question. After that, continue the video, watch the solution of this question. First question says define relaxation time of damped oscillatory system. Damped oscillatory system means suppose you have a pendulum like that. If the pendulum is oscillate in natural, then its amplitude does not decay. Amplitude means the maximum displacement does not decay. This is natural. But in practical, we can see there is a friction at that point, and the air resistance causes the decreasing of the amplitude, and finally it becomes rest. This is actually damped oscillation system. In that case, the time in which the amplitude becomes 1 by e exponential times its initial value. That means after some time its amplitude a can be written as a naught by e. So this time in which the amplitude become its 1 by e times of initial amplitude, that is the maximum amplitude, is known as relaxation time. The time in which the amplitude decays to 1 by e times of its initial value is a damped oscillating system is known as relaxation time. Is known as relaxation time, right? Suppose at any the amplitude at any instant is exponential minus by t. The decay constant tau is given by after some time of that, so at any instant t, and there are some at this time t plus tau, it become 1 by e. So finally you will get tau equals to 1 by b, and b is the decay constant. So tau is the relaxation time. Next question, what do you mean by sharpness of resonance? In LCR circuit or this type of circuit, you know the frequency, the power varies with frequency like that, and if the nature of the curve is like that, that is the bandwidth is very low, then what happen at a particular frequency its power will be maximum. It's mean it's like a absorptor or the sharp point, that is in case of radio or TV, you know, the previous or old radio, you know, there is a sound, beep sound at the wrong range. But nowadays this bandwidth is very small and its sharpness is very high. That's why its frequency matches at that point. So the rate of fall of response with departure from the equal between driving frequency and the resonant frequency gives the measure of sharpness of resonance. So in case of pendulum, you can see in case of pendulum there is decay. We just discussed about the damped oscillatory system. So this decay can be prevented by applying external force. If you apply the external force, this is external force. If you apply external force, then it's become its natural frequency when the oscillation of its frequency and the external force frequency are the same, and this condition known as the resonance. And that for that resonance, the sharpness is defined as this omega naught by delta omega, that is resonant frequency by bandwidth. Delta omega is the bandwidth. So in figure 1 you can see the curve 1 is more sharper than the curve 2, because the bandwidth of the curve 1 is less than of that one. So this is more sharp. Next question said find out relation between group velocity and phase velocity. Group velocity means the combined velocity of the wave within a group or the package of wave, and phase velocity is the individual velocity of the waves. You know the omega equals to k Vp, omega angular frequency k, wave number, Vp is the phase velocity, and Vg is the d omega by dk. So if you taking the derivative with respect to k in the both side, that is d omega by dk equals to Vp plus k dVp by dk. So d omega by dk is Vg. So this can be written as, and if you change the variable k to lambda is like that, and you know the lambda equals to 2 pi by k. So if you find d lambda by dk is nothing but 2 pi by k square, and k is substituted here 2 pi by lambda, so this become minus lambda square by 2 pi. So if you put this value of this one, you finally obtain this one, because this also becomes this value of k written here and finally cancel out. So this is the relation between group velocity and the phase velocity. Vg is the group velocity and Vp is the phase velocity, lambda is the wavelength of this signal. Next question, state Huygens principle. This already discussed in previous two lectures, that is when a primary wavefront, this is the wavefront, this is the primary source, at every point of the primary wavefront act as the secondary source point. So this every point on the primary wavefront acts at a secondary source point, and they emit the secondary wavelet, and the superposition of the secondary wavefront becomes the wavefront of the primary source. Okay, so this is written here. Every point of any wavefront of a primary source become the secondary source and emitting secondary wavefront. The superposition of the wavefront of secondary wavelets become the wavefront of the primary source. Right? I think clear. Next question. What will happen when Newton's ring experiment, the glass plate replaced by a plane mirror? That is, you know, in general, this glass plate on the lens on the glass plate, the air between these two things becomes the some path reference of two ray, and which result the interference for reflected light as well as transmitted light. But when you apply the mirror in place of this glass, then what happen? Total light reflected, and total reflection of light becomes the more illuminated. That means it does not become interference pattern, because the reflected part has more intense, the intensity will be very high, and one is more intense becomes the no bright dark alternative, because there is total illuminated. Okay, so the brightness is the much higher than the dark, and this becomes its just like illuminated, because you know, in case of bright but their intensity will be like that, but when the intensity is very high, this falls like that will be. So this is general illuminated region. So in general, the air between the glass makes the thin film path difference interference pattern. But in Newton's experiment, if a glass plate replaced by plane mirror, then the light totally reflected from the mirror, and it illuminated, and interference pattern observed. No interference will be observed. Okay, so just like a general illumination will be observed. Next question says, what is the shape of the interference fringe obtained Michelson interferometer? Explain. This is a Michelson interferometer setup. This is the lens, this is the source, this is the source, this is source. There are two mirror, M1 and M2. There are two mirror, this is M1 and M2. Its reflection represented here. So if you, this is observer, you can see this is observer, and this is half silver plate, some is reflected, some transmitted, and this is transmission, this is half silver, this is transmission. So these two superimpose, this light and this light becomes superimposed. There is difference of path difference, and this slight path difference becomes the result the interference pattern. The angle between these two mirror, if like that, if this one, then the fringe will be like that. So if this one, this is curved like that, and for that one this is, and the cross they, so their position can be changed by the screw, and finally you will obtain this fringe. Okay, the angle between M1 and M2 determine the shape of the interference of the fringe like that. Next question, when will the interference pattern found by two coherent wave be more distinct, for equally intense wave or for waves with widely different intensity? That means, you know, the interference will pattern from the wave comes from through source S1 and S2, their intensity, if I1 and I2, this intensity at that point will be prominent, or the question says that the interference pattern of 2 points is more distinct. The intensity pattern will be more distinct. More distinct means light and dark can be distinguished, right? Separately distinct can be when the intensity of I1 I2 are nearly same or the widely different. You can say, see, the resultant intensity of two waves come from source S1 and S2. It's become I equals to I1 plus I2 plus 2 root under I1 I2 cos phi, where phi is the phase difference. For bright fringe, this phi equals to 0, that is the same phase. Then I maximum will be like that, root under I1 plus root under I2 whole square. For dark fringe, this phi equals to minus pi, that is out of phase. This minimum intensity will be I1 plus I2 minus 2 root under I1 I2. This become root under I1 minus root under I2 square. If I1 and I2 are nearly equally intense, then what happen? I min is 0, I max is 4 I1. But when I1 is very much greater than I2, then I min is I1 and I max also I1. So this will be like general illumination. This is like general illumination. General illumination. So this is become like general illumination. But here you can see the minimum is 0, maximum is 4 I1. So there is distinct or interference pattern will be obtained. Interference. So interference pattern will be obtained when the intensity of the two light from these two source, coherent source, will be nearly equal. Then the interference will be prominent. When the intensity of one light is much greater or their difference is much higher, then what happen? There we can say general illumination, which already discussed in this question. That is, here you can see this reflected part is more intense. So this high intensity light gives you the general illumination. Okay, so I think correlate these two questions like that. So go to the next question. Question number 2a says a particle of mass m is located in one dimensional potential field where the potential energy of the particle depends on the coordinate x, like that. So this is the potential which depends on the position, is position x, where v0 and b are the constants, so that for small value of x the particle will execute simply that is, this is the potential. For equilibrium, you know the potential is 0, first derivative is 0 for equilibrium. So if you take the first derivative 0, is become like that. So x is 0, but x is displaced from the equilibrium at any instant. Then you can say this is the wave equation and this is the equilibrium position. But if you displaced this some position, then at for lower angle beta sin beta x can be written as beta x. So finally you will be obtain this equation, and thus corresponding this is the simple harmonic motion, you can see, and the corresponding time period will be like that. Okay. Next question says two mutually perpendicular simple harmonic motion of same period but different amplitude and phase act on a particle. Suppose there is a single particle like here, and there is two wave coming on perpendicular to wave with different suppose these two equation can be written as this is y equals to b sin omega t plus theta, and this is x equals to a sin omega t. So if you on a single particle these two waves superimpose, then what happen? The resultant displacement of this particle will be like that, that is y equals to b sin omega t plus theta, that is y by b equals to like that sin a plus b formula. and this another wave x equal to a sin omega t. So x by a equals to like that. So if you put this value cos sin omega t x by a, and cos omega t is root under 1 minus sin square omega t. So this is, so if you separate out this one and taking the whole square in both sides, you will be obtain this equation. I think you can do this calculation. After that if you after that question says under what condition trajectory will be circle. So this is the general equation ellipse. This is the equation of ellipse. Okay, now this we got general equation of ellipse. General equation of ellipse, right? Now if you put the theta equals to 90 degrees, sin 90 is 1, cos 90 0, this become ellipse. When these are the same phase, f equal to b, then becomes a circular path. So the question says under what condition trajectory will be circular. The condition are these two, that is the phase difference between these two f is 90 degree and the amplitude of these two signal must be equal. So these two condition gives you the circular path. Condition of trajectory circular, right? Next question say find out the expression for displacement of a particle undergoing damped simple harmonic motion and discuss when we get oscillatory damped simple harmonic motion. So if you consider a mass m oscillatory along the x direction, or you can see this pendulum will be or you can say like that a spring. So this becomes along the same direction, okay, x direction. So for that type of motion, that is displacement from the position of the equilibrium, damping force proportional to the instantaneous velocity, that is dx dt. The equation of the motion of such an oscillation is m d2x dt square equal to minus sx minus rm dx dt, where s is the restoring force per unit displacement and r is the damping force per unit velocity. So this is the reduced form or general form. If you take the trial solution of this equation x equal to c alpha t, taking the derivative and put this value in this equation, you will be obtain this is actually this is the differential equation solution process. So finally you will be obtain this relation. So this is the displacement of particle under simple harmonic damped harmonic motion. Now if you change the condition says and discuss we get oscillatory damped motion. For oscillatory damped motion, this omega naught is greater than b, that is becomes the complex part. This complex part gives you the sinusoidal or cosinusoidal formation, that is the oscillatory system. Otherwise if this b is greater than, then it will just decay, that is just decay means critical decay or over damped motion. That is if you take this pendulum like that, it stop here, but here this is oscillatory, but amplitude is decay, but it is oscillatory. If you just in the separate plane, so their damping will be like that. Okay, so this is the condition. Next question say define logarithmic decrement and derive in a relation. So you can see in damped oscillation the amplitude will be decay. The ratio of two successive amplitude on the opposite side, this is on the opposite side, is called the decrement. This is the decrement, and the logarithm of this decrement is known as the logarithmic decrement. Okay, so this log of a1 by a2 is known as logarithmic decrement. Suppose you consider at any time t1 it's become maximum like that, and after that it's become again maximum in opposite side. The time difference is t by 2 because this is the total time period, their half is t by 2. So if you add this time with that one, you will be get a2. So a2 equal to like that. If you taking this derivative difference or ratio, it will be gives you this one, and which is nothing but d, because you know a2 a1 by a2 is d. Taking the logarithmic, you will be get this one logarithmic decrement. Okay. Suppose this is very faster, then we cannot measure two successive. So if you measure for nth term, that is a1 is for first amplitude and an plus 1 is the nth amplitude, the ratio will be like that, a1 by a2 is this one. So there is d, this decrement will be the same for each two successive amplitude d to the n. So lambda will be obtained this one. So this is the logarithmic decrement expression. Next question says, for a stress string of length L, the displacement is given by this one. This is the displacement of a stress string. Okay. Find the total energy is this one. So, for displacement is this one. So, kinetic energy is nothing but 1 by rho A del y del t del x square. Rho is the density of the air, A is the cross section area. If you put this value, this one, so taking the derivative of this one and take the summation form into 1, and this integral will be like that. Actually, this is the mathematical, I think you can understand. So, just taking their K value and the potential energy is this one. So, if you take the summation of these two, add total energy is like that. Okay. So, I think you can do this. There is a mathematical calculation something. Next question say, what do you mean by logarithm longitudinal and transverse wave? Write down the one dimension differential wave equation and solve it for the plane progressive harmonic wave. Longitudinal wave means when the wave direction and the particle motion in the same direction or opposite direction. So, in the same direction is the longitudinal. When they are perpendicular, then this is transverse wave. When the movement of the medium is the same or opposite direction to the wave, which acts as the one dimension, this is the produce any medium like gas, liquid, solid. So, this is the longitudinal wave. Transverse wave when the movement of the medium in particular direction, medium, or you can say this is particle or medium particle, you can say. This can be medium particle is perpendicular direction to the wave which act in the two dimension. This wave can be produce a solid medium. Okay. So, this is longitudinal and this is transverse. Write down one dimension differential wave equation and solve this for plane harmonic wave. So, the one dimension progressive wave in can be written as like that, del 2 psi del t square del 2 psi del x, where psi is the function of x and t. The solution can be taken as the separation of variable. This is the partial differential equation. So, its solution can be obtained from the separation of variable. Take psi is a function of x and t is the x of x and t of t, that is capital X is the function which on function of small x variable x, and capital T is the function which is function of small t variable t. So, taking this derivative, double derivative and divide it, you can easily find out this expression, taking the separation constant and those two separate out this one, that one, and this equals to this one. You will be obtain these two equation and its solution will be like that, and their product will be the total solution of this. Okay. So, you can see the total solution is a function of these two, that is Ct minus x and Ct plus x. Next question, discuss briefly the phenomena of interference with relation to law of conservation of energy. That is, when there is two signal or two monochromatic light with intensity I naught. If we take the intensity as the same, that is the I naught, then the total intensity of the falling light or the light which are fall on this screen are 2 I naught. The intensity resultant intensity will be this one 4 I naught cos square phi by 2. We just taking this formula, you can see this is the total intensity formula we already discussed one. Okay. So, if you take these two are equal, then what happen? I0 to I0 cos phi, taking just from here you can easily get this relation 2 I0 plus 2 I0 cos phi, taking this 2 I0 common, 1 plus cos phi equal to 2 cos square phi by 2. So, you will obtain 4 I0 cos square phi by 2, okay, which we want to say here. Okay. Okay, this one. Where if there is no phase difference, that is phi equals to 0, cos 0 is 1, so this is 4 I0, and phi equals to opposite direction, when the phase difference is opposite, then what happens, phi equals to pi, that is I mean is 0. So, their average value will be 4 I0 by 2, that is 2 I0. Clear? So, you can see the incident intensity is 2 I0 and their intensity resultant average intensity in the screen of the light will be also 2 I0. So, you can say easily the energy is conserved here, that is the total intensity of the slide distributed on the screen in light and dark. Here the intensity is distributed from dark to light, that is the energy is conserved here. Next question say, how does interference take place in a thin film so that the reflected and transmitted interference pattern complementary to each other? Suppose this is a thin film with a angle like that, and there is a light reflected from that one and reflected from that. There is a path difference due to this thickness of film. This path difference, this small path difference gives you the interference pattern. So the path difference of the two reflected interference beam will be like that. You can see this path difference will be this, or this is the refractive index of this film. N is the refractive index of the film. N is the refractive index of thin film. Then the optical part will be Qn1 plus N1R plus Rs. So this is the N. This light follow within this medium, that is N Qn1 plus N1R plus Rs, minus Qn. This is the air. This is the air medium. So after that these two are same path. So path difference happening here, right? Here you can say that Rs equals to Sm. Rs equals to S M. This is actually M. This point actually M. Rs equals to Sm, and SL, this is SL equals to Lm, which is D, thickness at this film. This is the thickness at that point. So N, refractive index is sin I by sin R. This is I and this is R. So sin I, this I, so this is also I, this angle also I. So sin I can be written as perpendicular, that is Qn by Qs. Actually this is I, and sin R Qn1, this is R, by Qs, perpendicular by hypotenuse. Actually this angle is I1, this angle is R. So you will be obtain this relation, right? So if you put this value L equals to N Qn1, that is N1R plus Rs, Qn1, Qn equals to N Qn1. So these two are cancel out, only obtain N1R plus Rs, N1R plus Rs, this one, and Rs is nothing but Rm. So this is N1M, this is N1M, and this is nothing but 2nd, this is 2d. So this is the N1M is the 2d cos R minus alpha. This is R minus alpha 2 cos R minus alpha. Clear? Due to reflection at Q, additional path difference happen here. So there additional path difference, that is lambda by 2 happen here if you just adding this thing. Now the condition is the maximum will be the even multiple of this one. Since there is a lambda by 2, so this become finally odd multiple, and this is even multiple here. In case of transmitted light, so you can see for maximum this is odd multiple, for minimum this is even multiple, right? So this is maximum for odd, for minimum this is even. This is the condition for reflected light. In case of transmitted light, this light becomes from reflected from here, this is the transmitted light, and this transmitted light have a path difference here. You can see this path difference makes its interference pattern. Okay, the path difference of two transmitted beams is like that. You can see that is R, up to that point this is same, this is different, and this one. So R N1 plus N1S plus ST minus this Rn. Here you can see that is St. Here you can see that is St equals to Sm and Lt equal to Lm, which is d at the thickness of this film at that point. Hence, the refractive index n equals to sin I by sin r, which is r minus alpha actually. This is r minus alpha. So, you can write this is sin I equals to Rn by Rt. Rn by Rt. This is I. I1 and I is the same actually. I think this is I1. Here we can take the r minus alpha angle. R minus alpha angle. Okay. So sin I1 equals to Rn by Rt. Rn by Rt perpendicular by hypotenuse, and sin r minus alpha is Rn1 by Rt. So finally we obtain Rn equals to n Rn1. So the L can be obtained using this relation. You can see that is Rn is n R1, n R n1. So these two are cancelled out. Only obtain this one. So n1s plus Sm, that is total n1m, can be obtained from this triangle, that is 2nd cos r minus 2 alpha. So maximum value, this is r minus alpha, this is r minus 2 alpha, you can see. So the maximum value will be after even multiple and minimum is the odd multiple. So maximum is even, minimum is odd, but here you can see maximum is odd and minimum is even multiple, because due to the additional phase difference pi by 2 obtain additional phase difference pi by 2 due to pi, additional phase difference pi due to reflection, but there is no reflection phenomena here from rarer to denser medium. The reflection when rarer to denser medium, there is a additional phase difference. Okay, so here there is no like of additional phase difference, that's why there is no additional path, that is lambda by 2 is added here. That's why you can see for maximum and minimum condition is the difference. So the condition for maximum and minimum reflected is the complementary to each other. Okay, that is the condition for reflection. Maximum in case of reflection is the condition for minimum in case of transmitted. Next question says, so that in 2 dimension the shape of fringe produced in Young's experiment is hyperbolic. Why these fringes are called non-localized? So this is the setup of a Young's double slit experiment. This is the setup of a Young double slit experiment. You can see. So this is the 2 monochromatic source point S1 and S2. Here is one wave, there is another wave. So they superimpose here. So by trigonometry, by geometrical shape, you can see this S1p is the y square plus x minus d by 2 whole square, and S2p is 1. So their path difference is the difference. So just taking this difference and take this in the same side after calculating cos squaring, and this two y square is cancelled out, and this 2 gives you 4ab formula, and this gives you the final expression like that. I think you can rearrange them, and finally this equation will be the equation of hyperbola. So this is the hyperbola equation, and the nature will be this one with the eccentricity like that. Since the fringe can be obtained on the screen whereas it is placed, so these fringes are non-localized. That means if you change the position of the screen, then the pattern or the fringe can be obtained with the different fringe width. But this fringe actually appears wherever you place the screen. This is the screen. This is the screen. So wherever you place the screen, you can get the fringe, interference fringe of the screen on the skin. That's why this is the non-localized fringe. The fringe are the not in a particular point or the not localized. That's why this is called non-localized fringe. Next question says, what do you mean by fringes of equal width and fringes of equal inclination? Fringes of equal width means the fringe appear, the interference pattern fringe appear due to the light comes from the point where the thickness of the film are same. Like Newton's ring experiment, you can see here the thickness is the same, is the circular, that's why Newton's ring are the circular fringe, right? So you can see the incident ray are parallel or monochromatic, hence n are constant. Under this condition, different order of the fringe will be controlled by the thickness or d of the film. Hence a fringe of a particular order number will be the locus of the points of the film having the constant thickness. Whereas equal inclination means the equal inclination at a particular point, the inclination will be the same and the fringe will be appear. Example is the Hitner's fringes. Next question says, that is in Newton's ring arrangement with a source emitting two wavelength lambda 1 and lambda 2, it found that mth dark ring due to wavelength lambda 1 coincide with the m plus 1th dark ring due to lambda 2, so that the radius rho m of the mth dark ring for lambda 1, if the radius of the curvature or length is r, is given by this one. So the diameter of the mth dark ring of the Newton's ring, we just says that Newton's ring will be dark and bright in a circular pattern. So this is dark, this is bright, it is dark. Okay, like this one, right? So the diameter of the mth dark ring is the Newton's ring arrangement is this one. This is the diameter of the mth dark ring, right? Mth dark ring diameter will be like that. The radius is the half of this diameter. So the mth dark ring of n1 coincide with the m plus 1th dark ring of lambda 2, lambda 1. So just put the value of lambda 1, lambda 2. If you equating, the value of m will be obtained. So rho m is can be written here for in place of the m value. Just obtain this expression. Easy. Next question says, that is, find out the missing order in a double slit diffraction pattern. Find out the missing order in a double slit diffraction pattern. That is the missing order of double slit experiment. Suppose there in double slit experiment, you know the diffraction pattern and interference pattern are superimposed. Due to double slit, there is a origin of the interference pattern, and due to slit there is a origin of the diffraction pattern. When the dark or the low intensity or the constructive or you can say the condition for the constructive interference coincide the destructive diffraction condition, then what happens? The final will be 0, because at that point the diffraction gives you the minimum value and the interference is the maximum, their product will gives you the minimum value. So at that point there is a missing of the constructive interference pattern here. So this is known actually the missing order of the interference pattern. The condition for the dark band of the diffraction is like that. Condition for the bright band of interference is like that. At a particular point or the angle, at a particular angle, these two are same. That is, the bright fringe of the interference is coincide with the dark fringe of the diffraction, and the finally there is becomes a dark band. There is no bright band, right? So at that condition, if you equating these two things, you will finally obtain this relation. And this ratio of two integer, if we consider these two integers is like that, you can see these 2, 4, 6 structure order of interference are absent because they coincide with the minimum condition or the dark condition of the diffraction pattern, and this is known as the missing order. Next question say a parallel beam of sodium light is allowed to incident normally on the plane grating, this one is line per centimeter, and the second order spectrum line is observed to be derived through the 30 angle, calculate the wavelength of the spectrum. So the transmitting grating, the d lambda sin theta equals to n lambda, the number per lines is the 4250, that is d equals to 1 by n, change centimeter into meter, and theta is for second order, that is n equals to 2. You can easily find out the wavelength of the spectrum line. Next question say explain various criteria of resolution. Actually, the diffraction pattern from these 2 points, suppose 2 point dot source, suppose the diffraction pattern from these 2 points is like that, they are distinct, but when their separation is like that, they cannot be distinct out. Okay, so this is the condition below that which the deep cannot arrive. If deep cannot arrive, so the deep is not be formed. If this is deep is not formed, then these two if the so the if this deep is arrived, then you can distinguish these two particles, but when they are closer, they superimpose, their diffraction pattern are superimposed, then what happen, you will be get a single particle. So if you just taking these 2 points on a paper, and if you observe from a far distance, you can see this is a single point. This is the Rayleigh criteria. According to the Lord-Rayleigh, 2 equally bright point source could be just resolved by any optical system if the distance between such that central maxima in the diffraction pattern due to one source coincide exactly the first minima. If these first minima coincide, there is a deep arise, and this is the condition of Rayleigh's criteria. If that distance is much closer, then these two deeps are not arise and they are single point. Okay, so I think clear about the Rayleigh's criteria. If there is any doubt, you must comment in the comment box. This is all about me. This is my contact details, and this is my YouTube channel. In next class, we will be continue about the solution of the year 2023. So I think clear. If there is any doubt, you must comment in the comment box. Take care. We will meet in the next video as soon as possible. Thank you.